Hello everyone. So in this question, we have to predict whether a car will be stolen or not given this data, the color of the car, the type of the car and the origin of the car. Okay. So let's say first we check for the color attribute. Okay. So we are deciding the root. Okay. Deciding the root node, the first attribute on which we can split, deciding the root node. Okay. So for color, we have three values. Color equal to, if you see, color can be red or color can be yellow. No, in fact there are only two. Okay, red or yellow. Color can be either red or yellow. Okay. Now we have to calculate the Gini impurity for both of these values. So Gini impurity for red. For this calculation, what we'll need is how many cars which are red. So how many cars are red? Firstly, car number 1, 2, 3, 9 and 10, they are red. Out of these, how many are yes and how many are no? Okay, so out of the red cars, 3 have been stolen and 2 have not been stolen. Okay, so the Gini impurity of red will be given by 1 minus the probability of yes minus probability of yes squared minus probability of no squared. So this, if you calculate, it comes out to be 12 upon 25, which is 0.48. Similarly, calculate for yellow. If you calculate Gini of yellow in a similar way, so you will find that yes, okay, 2 yellow cars have been stolen and 3 yellow cars have not been stolen. Okay, so therefore Gini of yellow will be 1 minus, again it's the same value. Okay, I need not even calculate, but see, 1 minus 2 by 5 square minus 3 by 5 square, so that will also be 0.48. Okay, now we have to calculate the weighted Gini impurity value for the attribute color. Okay, so Gini of color, now we'll assign weights. Now what will be the weight of yellow? So if you see carefully, 5 cars are red, so 5 by 10 times 0.48, and 5 cars are yellow, so 5 by 10 times 0.48, which perfectly comes out to be 0.48. So just remember this value, that the Gini index value or weighted Gini value for color is 0.48. Now consider the second possible attribute for splitting, which is the type attribute. Okay, so let's say again for type attribute, again there are 2 types once again. Either there are sports cars or SUV cars, and there are 6 sports cars and 4 SUVs. Okay, so if now instead of writing Gini every time, let's say I want to calculate for type equal to sports. So if you see, for sports cars, 4 sports cars have been stolen and 2 have not been stolen. So the Gini impurity of sports will be, by now you must have understood the pattern, it is 1 minus the probability of yes it's stolen, so 4 by 6 square, minus the probability of no it's not stolen squared. So if you calculate this, this comes out to be 0.44. So now for type equal to SUV, calculate the yes values. So if you see, only 1 SUV has been stolen and 3 SUVs have not been stolen. So Gini of SUV is 1 minus 1 by 4 square minus 3 by 4 square. So this comes out to be 0.375. Okay, now weighted Gini for type. Gini for the whole attribute type will be calculated by the weight of the type sports. So weight of type sports is 6 out of 10. Right, 6 out of 10 multiplied by the Gini impurity value, that is 0.44, and these are 4 out of 10, SUVs are 4 out of 10, and its weight is 0.375. Okay, so this comes out to be roughly 0.417. Okay, so Gini of type is 0.417, Gini of color was 0.48. We have already found a lower candidate. Basically, whichever attribute has the lowest weighted Gini, that attribute will be chosen as the root node. So 0.48 was color, and we have already bested it with type. Okay, so now let's continue our search for the root node. Okay, third attribute is origin. Okay, so origin has different values. Firstly, how many possible values? It has only 2 again. Origin can be domestic, and there are again 5 rows with domestic as the origin, and 5 rows or 5 cars which were imported. Now out of domestic cars, how many have yes? 2 domestic cars were stolen and 3 domestic cars were not stolen. Now from your previous calculation, you already know the Gini value for this. So Gini for origin equal to domestic is 1 minus 2 by 5 square minus 3 by 5 square, and you know that it comes out to be 0.48. Now similarly for origin equal to imported. For origin equal to imported, yes is 3 values and no is 2 values. Again, show the calculation. So Gini of imported is 1 minus 3 by 5 square minus 2 by 5 square, which is effectively the same thing, that is 0.48. Okay, and you also know what the weighted Gini is going to be. So weighted Gini for origin is going to be 5 by 10 times 0.48 plus 5 by 10 times 0.48 which is equal to 0.48, which is the same as color. So based on the weights, weighted Gini values that we saw, type has the lowest weighted Gini value. So therefore we'll choose type as the type 0.417 as the lowest Gini value, weighted Gini value, right? Lowest weighted Gini value. So therefore root is type. So we have found out the root attribute, SUV class, and the remaining ones, these are all sports. Okay, so now let's decide what is the next attribute that we will split on. So we have already used up type. All of them have the same type now, SUV, and this all of them in sports have the same type, that is sports. Okay, so let's split SUV on color. So again there are two colors, yellow and red. Okay, so we are dealing with the SUV branch first. Let's say we can take any branch first. Let's say we take SUV branch. In SUV branch, let's say we choose the attribute color. Okay, so let's say color. So color equal to yellow. For color equal to yellow, we have the cars 6, 7 and 8, out of which yes is for 1 and no is for 2. Okay, so the Gini impurity for color equal to yellow is 1 minus 1 by 3 square minus 2 by 3 square. Calculate this and it comes out to be 0.44, which is also a value we had calculated before. Yes, this is the same thing, right? 4 by 6 is 2 by 3, 2 by 6 is 1 by 3. So we had calculated this before. It's not that always this kind of a thing will be there in your numerical, but just be on a lookout key, are the calculations repeating anyway. So then for the color equal to red, yes values are 0 and no value is 1. Now this you can remember. If, so of course, like one of the probability values will be 0. So if I actually apply the formula, Gini of red will be, okay, so Gini of red will be 1 minus 0 square minus 1 square, which will effectively be 0. But you can remember that if you get an attribute for which all the values, so for example color equal to red ke liye you are getting all of them as no, that is there is only one, but that is no. Okay, all of them belong to the same class. Yes and no are classes. So if all rows for a particular attribute belong to a particular value of the attribute belong to the same class, then the Gini impurity for that value is 0. So Gini impurity for red is 0. Now the weighted Gini impurity, okay, still we have to calculate weighted Gini impurity for color. So weighted Gini impurity will be 3 by 4 times 0.44, okay, plus 1 by 4 times 0, which is nothing but 0.33. Okay, now let's calculate for the origin. Okay, so origin equal to imported. Origin equal to imported, there are 3 cars. Let me paste the table again over here. Origin equal to imported, and again what am I dealing with over here? Only this particular small tiny subset, right? So origin equal to imported amongst these. Origin equal to imported, yes. Okay. Yes, so amongst imported, yes is present for only 1 and no is present for 2. Okay, so again like this is a familiar thing. So Gini of imported will be 1 minus 1 by 3 square minus 2 by 3 square. We have seen it before, it is 0.44. Okay, and then origin equal to domestic. Now for origin equal to domestic, again you can see there is yes equal to 0 and yes equal to 0 and no equal to 1. So therefore Gini of origin equal to domestic will be 0. Okay, so if you again calculate the weighted Gini, okay, weighted Gini of origin, the weighted Gini will be 3 by 4 times 0.44 plus 1 by 4 times 0, which is equal to 0.33, same as color. Okay, so now next let's, what is left? There were only 2 left, right? So now what we'll do, there is a tie now, there is a tie, right? Both color and origin have the same weighted Gini, so there can be a tie. In case of tie you can choose either. So now what I will do is I will choose color. So if I choose color, you could also choose origin, but let's say I choose color. So now my tree will be something like this. Type is either SUV or sport, and amongst SUV now I am next choosing color. So color equal to yellow or red. Okay, now SUV color red, this becomes a leaf node. Okay, this becomes a leaf node. So this is no. Okay, if you see SUV, red SUV is not stolen. Okay, so red SUV is not stolen, so no. And now yellow SUV. Now for yellow SUV, you again have to decide. The only attribute left is domestic. There is nothing to decide. The only attribute left, only remaining attribute is domestic. Okay, so I will show the types like this just to distinguish, right? So the only attribute for splitting, okay, that is origin. Okay, and the origin in this case, okay, if it's domestic, then it's no. Okay, you can see amongst yellow. Okay, I'm focusing on this even tinier subset. Okay, amongst yellow. So if it's imported, it's okay. Yeah, and for imported now we have two values. Okay, so for imported, it's okay. There is no majority over here in this particular numerical, because car 6 is yellow SUV imported and it has yes, and car 7 is yellow SUV imported but it is no. Okay, so same attributes but different class labels are there. So perfect separation is impossible here. So by majority of the parent node, because yellow SUV has two no's and one yes, so this leaf will be labeled as no. Okay, so we'll label it as a no. Okay, just because the parent node yellow has parent node yellow SUV has two nodes, right? Because amongst the yellow SUVs the majority is being no, right? So therefore we'll write, or we'll decide that if it's a imported yellow SUV car, then it will not be stolen. Okay, now let's expand on the other branch, that is the sports branch. So again, for sports branch we'll perform a similar calculation. So for sports branch, now the subset we are working on is a larger subset. This is the subset that we are working on for sports. So in sports branch, here you can see first we can split on color. So color is red. So for color equal to red, you can see there are 4 cars, and out of those 4, 3 have yes and 1 has a no. So this was also one of the calculated values before. So Gini of red is equal to 1 minus 3 by 4 square minus 1 by 4 square. So this is equal to 0.375. This was also calculated in one of the earlier attribute calculations. Now similarly for color equal to yellow, yes equal to 1 and no is equal to 1. So therefore Gini of yellow is equal to 1 minus half square minus half square. So this comes out as 0.5. And weighted Gini for color comes out to be 4 by 6 of 0.375 plus 2 by 6 of 0.5, which is 0.417. Okay, next let's decide on origin. Okay, so among the sports cars, origin is domestic and imported. So for origin equal to domestic, yes is equal to 2 and no is equal to 2. So you can remember, you can show the calculation, or you can simply remember that when yes and no are equal, then the Gini is simply 0.5. So Gini of domestic will be equal to 0.5. Now when origin is equal to imported, you can see that there are 2 yes values and 0 no values. So in that case all of them belong to one class, so the Gini value will be 0, and the weighted Gini value for origin will be 4 by 6 times 4.5 plus 2 out of the 6 rows are basically origin equal to imported, and for them it is 0, and so it will be 0.33. So it's 0.33 for origin and 0.417 for color. So now there is no tie as such. Okay, so now our tree is going to go like type. So okay, let me just let me just work over here. So in sport, now I will use origin as the next attribute to split. Okay, origin is my next attribute, and origin, now within origin, now let's do the simpler part first. When origin is equal to imported, then it's always yes. Okay, and when origin is equal to domestic, now take a look at the table. When origin is equal to domestic, there are 4 rows for origin equal to domestic. I am looking here, right? So in these cases, for yellow it's simple. For yellow it's no. Okay, for yellow it's no, and Okay, now this is another shortcut if your time is less. For yellow, it's no. And for red, just check the majority. For red, the majority says yes. So for red, it is yes. Okay, I will just denote the leaf nodes by some other color. Okay, so these are the blue. Okay, leave it. So these are the leaf nodes. Okay, so that is the answer. That is our final tree. That is how Gini index problem is solved. This is also called as the card classification and regression trees. Although we have used it for classification exclusively over here, it can also be used for performing regression. If you have any questions, any doubts, do post them in the comments below.